All right, welcome everyone. In this explainer, we're going to break down the core networking concepts you absolutely need to know for your Cisco and Pearson IT Specialist certifications. So if you're getting ready for that exam, you are in the perfect spot. We're going to make all this stuff super simple and easy to remember. Okay, so here's our game plan for today. We're going to start with the absolute basics, the rules that let computers talk to each other. Then we'll get into speed and the different sizes of networks. After that, we'll look at how to draw network maps, figure out where our data actually lives, and finally, learn the common languages that networks use. First things first, let's talk about rules. Just like two people need to speak the same language to understand each other, computers also need to agree on a set of rules before they can communicate. These rules are basically the language of the network. So, for devices to actually talk to each other, we rely on two main sets of rules, or models. Over on the left, you see the OSI model. Think of this as the perfect blueprint. It's a 7-layer guide that helps us understand every single step of network communication. We learn it because it explains the theory perfectly. Then on the right, you've got the TCP/IP model. This is the real deal, the 4-layer model the actual internet uses every single day. So OSI is the theory, TCP/IP is the practice. One of the best ways to picture the OSI model is to think of it like a 7-layer cake. Seriously, each layer of that cake adds something new and important to the recipe. Well, in networking, each layer does something special to prepare our data before it gets sent out, all the way from the app you're using at the very top down to the physical wire at the bottom. Now, here's something interesting. When you send a big file, your computer doesn't just shoot the whole thing out at once. Instead, inside those layers we just talked about, it breaks your data into small, easy-to-handle pieces called packets. Then, to make sure every little piece gets to the right place, it's put inside something called a frame. A frame is basically a digital envelope, with the to and from addresses stamped right on the outside. And listen, this isn't just something you memorize for one test and then forget. Seriously, this stuff, it's the foundation for so many other IT certifications. Whether you go for your CompTIA Network Plus next, or you jump into cloud computing with AWS or Microsoft Azure, you are going to see these layers again and again. They're that important. All right, let's put this to the test. Here's a question you might see on your exam. Think about it for a second. Which of these layers is the one in charge of finding the best road for your data to travel? Is it A, B, C, or D? And the answer is C, the network layer. The easiest way to remember this is to think of layer 3 as the GPS for your data. It looks at the destination IP address and figures out the best possible path for your packets to take to get where they're going. And that whole process, it's called routing. Oh, right. Let's build on that. Now that we have the rules down, let's talk about performance. How fast is our network really? And how do we describe different networks based on how big they are? Okay, this is a big one, because people get these two mixed up all the time, bandwidth and throughput. For your exams, you absolutely have to know the difference. Bandwidth is the potential speed. Think of it as a huge 5-lane highway. That's how much traffic it could handle. Throughput, on the other hand, is the actual speed you get, with all the traffic and slowdowns included. So when you run an internet speed test at home, you're measuring your throughput. So if bandwidth is the big, wide highway, why are you almost never going at the maximum speed limit? Well, just like a real highway, you've got traffic jams. Things like latency, which is just the delay for your data to travel, other people using the network, and all the different devices your data has to pass through, they all slow things down. Okay, let's switch gears and talk about network size. We'll start with the one you probably use every single day, a LAN, or local area network. This is the network that connects everything in your home, or in your classroom, or in one office building. It's all about connecting devices in one small local place. And this chart here really lays it all out beautifully. We start super small with a PAN, a personal area network. That's for things like connecting your phone to your Bluetooth headphones. Then we move up to the LAN we just talked about. A CAN connects multiple buildings, like on a college campus. A MAN can cover a whole city. And finally, the big one, the WAN, or Wide Area Network. And the biggest WAN of all, the internet. Okay, time for another question. This is a super common scenario. Your internet plan says you should get a certain speed, but when you run a speed test, the number is way lower. What are you actually measuring? Take a look at the options. The answer here is D, throughput. Remember the difference? The speed they promise you, the maximum possible speed, that's the bandwidth. The speed you actually get in the real world with all the traffic, that's your throughput. And a speed test always measures throughput. All right, next section. Let's talk about how we draw pictures of networks. In the IT world, we have a special name for these maps: topologies. So you got to know there are two main kinds of these maps. On one side, you've got the physical topology. Think of this like a building's blueprint. It shows you exactly where every computer, every server, and every cable is physically located. Then on the other side, we have the logical topology. This is more like a subway map. It doesn't care where things are in the room, it just shows you how data flows and how everything is connected with IP addresses. Now, the most common layout you're going to see for a local network by far is the star topology. You can see it right here. Everything connects to one central device, usually a switch. And there's a good reason it's so popular. It's reliable. If one person's computer cable breaks, it only affects them. Everybody else on the network can keep on working. So, here's your exam tip. Get really comfortable looking at these diagrams. I can almost guarantee you'll see a picture of a network on your CCST or Network Plus exam, and they'll ask you to name the topology. It's a skill you will definitely need. Okay, let's move on to a topic that is just everywhere these days: the cloud. We're going to look at how cloud services are different from the traditional way of doing things, which we call on-premises. So what's the difference? The easiest way to think about it is this. On-premises is like owning your own house. You have to take care of everything: the building, the electricity, the security, all of it. In IT, that means you own and manage all your own server computers. The cloud, on the other hand, is like renting an apartment. The building manager takes care of all the maintenance and security. You just pay rent and use the space. In the cloud, someone else owns the hardware, and you just rent the computing power you need. Now, to really get the different types of cloud services, we're going to use my favorite analogy: pizza as a service. It makes everything super clear. Let's start with on-premises. This is like making pizza at home from scratch. You buy the flour, make the dough, chop the toppings, you do everything. Now let's look at infrastructure as a service, or IaaS. This is like buying the pre-made dough and toppings from the store, but you still use your own oven at home to bake it. The cloud provider gives you the basic pieces, but you manage them. Okay, next is platform as a service, or PaaS. This is like ordering a pizza for delivery. The pizza shop handles making the whole pizza, you just have to worry about the plates and drinks. And finally, software as a service, or SaaS. This is the easiest one. It's just like going out to eat at a pizza restaurant. You just show up, order, and eat. They handle everything. And I can't stress this enough, knowing these as-a-service models, IaaS, PaaS, SaaS, is absolutely critical. This isn't just for networking exams. It is the core of any cloud certification out there. If you're even thinking about taking the AWS Cloud Practitioner or Microsoft AZ900 exams, you need to know this stuff cold. Okay, time to connect this to the real world. Think about a service like Microsoft 365 or even Google Docs. You just open your web browser and start using it. Which of the pizza models does that sound like? Yep, the answer is C, software as a service, or SaaS. Why? Because you're just using the software. You're not managing the servers, you're not managing the platform, you're not doing anything behind the scenes. You are just sitting down at the restaurant and eating the pizza. It's a perfect example of SaaS. All right, we're in the home stretch. For our last section, we're going to talk about the specific languages, or as we call them, protocols, that make the internet actually do things. Okay, so there are two big ones you have to know right away: TCP and UDP. Think of TCP as being all about reliability. It's like making a phone call. You pick up the phone, you dial, you wait for the other person to say hello before you start talking. It checks to make sure all the data gets there. This is perfect for something like loading a website. Now, UDP is the opposite. It's all about speed. It's like sending a postcard. You just write it, put it in the mailbox, and hope it gets there. It's super fast, which makes it great for video calls or online games where a tiny glitch is better than a long delay. And it's not just TCP and UDP. There's a whole team of protocols working together. You've got DNS, which is like the internet's phone book. It turns website names into numbers. Then there's DHCP, which is like an automatic address giver for your computer when it joins a network. HTTP and HTTPS are the languages used to bring websites to your browser. And of course, FTP and SFTP are like a special delivery service just for moving files. Each one has a very specific job. Okay, last question for you. When you type a web address into your browser, what's the very first domino to fall? Which protocol kicks things off before anything else can happen? The answer is C, DNS. And here's why that's so important. Computers don't speak in names like www.cisco.com. They speak in numbers, IP addresses. So before your browser can even ask for the website, it has to use DNS to look up that number. It's exactly like looking up a number in a phone book before you can make a call. All right, let's do a quick recap of everything we've covered. We talked about the rules. Networks need models like OSI and TCP/IP to communicate. We talked about speed, knowing the difference between potential speed, bandwidth, and actual speed, throughput. We looked at maps, how topologies show us what a network looks like. We broke down the cloud with our as-a-service models. And finally, we learned the languages of the internet, all the protocols that have a special job to do. So I'm going to leave you with one final question to chew on, and it's a big one that leads right into cybersecurity. Now that you know all these different pieces, the rules, the devices, the software, which part do you think is the hardest to keep safe? Is it the rules themselves, the physical cables and switches, or the applications we use every day? It's something to think about as you continue your journey. Good luck on your exams.